In this video here, we're going to learn how to sketch the graph of quadratic functions by using the simple step in graphing. So before we go on further, just for you to take notes, the technique we're going to use here will require to have the quadratic functions undergo the process of completing the square and have the following form below. Of course, as stated in the remark here, although some of the quadratic functions we can just easily be sketched by using factorizations. However, the technique using factorization is not discussed here because not all the functions can be factorized. And also, for quadratic functions, we can also have the techniques of differentiations of drawing. However, once again, it's not discussed here, where we will see that in chapter 10 later. So, again, the word simple steps in graphing is actually the acronym for the step that we need to have here, which is first we identify the type of functions, followed by the shape, the special point or lines, the interceptions on x and y axis, and last for graphing. And of course, once again, in order to perform these 5 steps here for the graphing, I need to have my quadratic happen to represent in this form here after we perform completing the square, where we have the terms written as a multiplied with a linear expressions square, and this linear expression comes with the x with the positive 1 as the coefficients, and then plus or minus with some constant. And now without further ado, let's have a look on the first step, the type of functions. What I mean by the type of functions here is, of course, we are discussing with quadratic function, and I want it to happen to represent in this form here, where the capital A here shall not equal to 0. Below we have some examples to see what are the quadratic function happens to have the form that we want here, have the type that we want here. So the first one, we have x squared plus 1, where if I compare with these general functions on top, you can happen to see that the a, h, and k is corresponding to positive 1, 0, and also 1. The next one, fx equals to negative 3x squared. You can see that negative 3 corresponding to the a. The h is 0. The k is also 0 as stated. For the third one, fx equals to 4x squared plus 20x plus 25. Initially, this function here is not written in the form that we require. So, however, we still can obtain the form that we want after by doing completing the square, and this is the result that we have. But you can find out that there is no constant k there, which is k equals to 0. The h, and also the a. Then the last one, also the similar idea. After completing the square, we can have the corresponding a, h, and k as compared with the formula on top. Next, after we have the form like what is stated here, the next thing what we want to do is that we want to determine whether what types the shape of the graph. In quadratic functions, we have the graph in the shape of smiling face when the time we have the coefficient of x squared happens to be a positive value. And with this smiling face graph here, we have a minimum point at the point with coordinate x equals to negative h, y equals to k, and this value here is obtained based on the form that we have in these functions here, where when the time we have the x plus h here equals to 0, so we get negative h, and the corresponding y will be k. And the following are the sum of the examples where we have positive coefficient of x squared, where the first one is the basic curve, the basic function y equals to x squared, y equals to 2 multiply x minus 1 squared plus 3, where we can see that when the time you expand, you have the coefficient for x squared is positive 2, y equals to 4x squared plus 8x plus 1, which is the general equations of quadratic, where we can see very obvious the quadratics functions come with x squared with the coefficient of positive 4, and lastly, y equals to 4 minus x squared. By the time you expand, you have the coefficient for x squared is positive 1. And by the time you have the case that you have the coefficient for x squared is a negative value, you will find out that we will have this whole graph here happen to flip vertically and have the shape of a sad face graph, where now it turns out that we have a maximum point, and the coordinate of maximum point we happens to obtain by the similar calculation like just now we do for the minimum point. And the following are some of the examples for the case that we have negative coefficient of x squared. Again, the basic case, y equals to minus x squared, y equals to negative 2 bracket x minus 1 squared plus 3, y equals to negative 4x squared plus 8x plus 1. So these are some of the case that we can see the shape of the graph. Again, the remark here, although the graph of quadratic can be sketched easily, sometimes just by factorizations. However, since not all the quadratic functions can be factorized, so completing the square is applied in the graphing technique here. Next, step 3. We talk about the special points that we have in quadratics. The special points that we have in quadratic is what we call the extremum point, which is corresponding to the maximum or minimum point as we see from the graph just now. And the way to obtain these special points here, we can obtain for the corresponding x coordinate by having the bracket terms here for the bracket square terms here, x plus h equals to 0. We solve it, we will have x equals to minus h. So minus h will be the x coordinate for the extremum point. Then the corresponding k that we observe here will be the y coordinates. And the following, based on the following examples, we can see that for the case x squared plus 1, if I want to compare with the functions we have on top, we will have x minus 1, x plus 0 squared plus 1. So therefore, the corresponding point that we have here for the extremum point will be 0, 1. And this is the case of minimum point because the coefficient for x squared happens to be positive. The next case, we have a maximum point at 0, 0, where we can see that the coefficient for x squared is negative. Then the corresponding x and y coordinate for the maximum point, if I happen to compare the function above, so this is what we have. Okay. Then the following two examples is very obvious, where we have here for the x is negative 5 over 2, 0 for y coordinate. We have the case of minimum point, as you can see positive coefficients for x squared. The other one we have a maximum point, negative coefficients, and these corresponding parts give the coordinate of positive 1 and 4. Then next we go on with the step 4, the intersections on x and y axis. So similar that what we have later, where when the time I want to determine the intercept on x and y axis, I need to find out that whether it exists or not based on the previous 3 steps by doing a rough sketch with the reference of the special point. For example, if let's say I happen to know that this is the shape of the quadratic functions, this minimum point is the special points. By using this point here as reference, I should be able to identify whether my x and y intercept exists or not. And in order to get y-intercept, we're going to obtain by the calculation substituting x equal to 0. To calculate the x-intercept, we will just solve using calculator considering the function equals to 0. Then once this x and y-intercept happens to identify, and now we will have the last step, which is sketching the graph. So once you have sketched the graph, please make sure you remember to label the x and y axis, the origins, the name of the graph, where if let's say we have functions of fx, so the name of the graph is f. If let's say you have function of hx, then the graph will label as h. Next, the extremum points. Depends you have the case of maximum or minimum, we need to label the point and also the corresponding coordinates. And lastly, the x and y intercept if they happen to exist. Therefore, this is how we go for the graph sketching for quadratic functions.